Good morning, everyone. Welcome to another day of bashing my hands against the proverbial wall. I was about to say it's bold of you to assume we have snow strudel. I think we had 2 snow days last year, maybe a few more. That's about it. Anyway, you catch the airport shuttle and you try to book a new flight to your vacation island. Due to the storm, all direct flights have been cancelled, but a route is available to get around the storm. You take it. 27 lines, you can do it before dying. Let's see. While you wait for your flight, you decide to check in with the elves back at the North Pole. They're playing a memory game and are ever so excited to explain the rules. In this game, they take turns saying numbers. They begin by taking turns and starting from a list of starting numbers, your puzzle input. Then each turn consists of considering the most recently spoken number. The turn, yeah? If that was the first time the number has been spoken, the current player says 0. Otherwise, the number has been spoken before. The current player announces how many turns apart the number is from when it was previously spoken. So that sounds like doing map crap. So after the starting number, each turn results in that the player speaking aloud either 0 or an H. 0 through 6, that's... Wait. Oh, then, comma, each turn consists. Okay, so it's not within each turn. It is first considers of this, and then it starts reading new numbers. Okay. Let's see, the second number is 3, 6. Now consider the last spoken number is 6. Since it was the first time, it's 4, spoken number 0. Then again, consider the last spoken number 0, since it had been spoken before. The number is a big difference between the turn number and when it's last spoken. And it's 1. Previous turn 4, and the turn number of the time was most recently spoken before. Turn 1, thus the fifth number spoken is 4 minus 3. Okay, so I thought, if the number, no, I see what they're gonna do. Yeah, so you consider the last spoken number. I thought it would be, oh, you say it since it's last been done before, we can subtract them. So that's why. But it's like, it's the same thing. It's literally the same thing. It's 3 turns ago it was said. They're just doing it in a really weird way here. The last number spoken 3 has also been spoken before, most recently on turn 5 and 2. That's so 1 turn before and 2. So again, 2, 3 turns before. To battery. I know, it's like a... It's something else. It's from Kirby, I think. I don't know. Some automated playlist from the same artist I usually listen to. Since 3 was just spoken twice in a row, the last 2 turns are 1 apart. It's Persona 5. Well, I'll believe you, I guess. It's called Rainy Day at the Cafe. I'll believe you. I haven't played Persona 5. But it might be that the remix has a different title. I don't know. Anyway, this one is new. The 8th spoken number is 0. 0 was last spoken on turns 8 and 4, so the 9th is the difference between them. Yeah, so this... it's one of those iteration things. I've seen this before. What is the 20th number that will be spoken? Okay. Let me see what my... Oh, that's a very short input. But it makes sense. Which means we're hard coding it, I guess. Are we gonna get double digits? Yeah. I have a... This is slightly easier if I do it like this, because then I can do... I think this works. So I'm pretty sure that this solution would be fairly simple. What we would do is we would create a queue. I'm gonna do a very simple, stupid solution. I've done this before. Was it in my seconds? What I've done is I've actually cleaned up my repositories a bit, so I now have 2017 in another folder. Because I'm pretty sure that I did something like this before, where I just kind of comma separated out everything. Yeah, it wasn't you. How was this everything? Wow. Yeah, this one. Oh, I just make it a string stream. That's the one. You're supposed to kind of remove the things from that. The commas, I mean. Here we go. Ah, yes. So now it should work. Just making sure. Yeah, so I'm pretty sure that for this one, I'm just going to keep a queue. And since you're only ever going to be doing 2020 as the highest value you're looking for, that's not very high. So what I'm going to do is I'm just going to have a simple vector, which is going to be a queue. Well, what do we call it? Turns? Yeah, let's call it turn. So turns, and then we just do turns.push. Turn push back n. So now what I do is I do a while. Well, no, let's keep it a bit better. So we do for int I equals 0. I is less than so normally it would be like turn limits int turn. Let's keep it at 10 now, so I can just see what the 10s are. Turn limits. And then we do I++. So one thing what I could do is keep the last known occurrence of a value in memory. I think that'll be needed for the second one, and if you don't just keep everything there. What you could do there is just a map. And I think that might be actually the best idea. The only issue is that I need to... So basically what we're going to do is... you always look at the last spoken number. So you need to make sure you're not overwriting the value you're actually looking for. So basically what we can do is, hey, my current value is 3. I know this value has already been spoken before, so even before we go to the last turn, so to the next turn, we're going to say, hey, I know next turn you're going to be saying this number. And then you go to that turn, and then you read it. And then you can safely overwrite this, because the last time this has been spoken is this. So that's fine. So that's probably the way we would do it. The smart way, but I don't care about the smart way. I'm pretty sure that'll be the issue that the thing we'll have to do in part 2. But I'm not going to do it because this is a way faster naive one. So what do we do is for this? So I've condensed my code into 6 lines. Impressive. So if the length is less, you just say it. Yeah. I guess here we can do count n, just so we have like the endl, because we know, and this can start from turns.size, I think. -1. There we go. So now we're starting at turn 4, but because we're 0 index, it's turn 3. So we're gonna first and then we'll say int last said equals turn limit turns dot size -1. So that's the number that was previously set, which in this case is 6. So let's go over the logic we need to have here. I'm pretty sure it's not that difficult. Yeah, so it's the first time the number is supposed. So what we do is we do a find. Oh, there's no find in vector, is there? That's the issue. 5 lines, nice. So let's do like, well, just say what we get. So int find val. Make it even less might be cheesy. Well, I mean, it's fine. So find val, and then you look for the value from the turn before. So that will be last int v. So we just do turns dot push back find val, because we always last said, well, actually no, because we should have int results. We could reorder this later, like the other method that I mentioned. So we should just do this. Last order is find val. Last all you guys do an iterative, and then you just do you push back then the latest set number, and we just, for good measure, we count it, and just do an I there as well. What? Oh, I'm pressing spacebar instead of shift there. Yeah, no wonder. No wonder. So we get that, and now we just find val. So this will just be. So what we need to do is we need to return the index, but I don't think turns.find. It doesn't have a find thing. So I think there is a search you can do, and then you have an iterator, and that iterator is either end or the value. But don't care about the value. We know we have the value. We want the index. So what we can do is we can just go cpp search vector. Yeah, basically what we want to do. So we want to do find, and p is going to be an integer. An iterator in the range that compares equal to val to the first element. But I want to know the index. Yeah, okay, so they do a pointer, but I want p itself. P is not equals minds.for, just minds.end. Yeah, the only issue here is, I think, it's because it's fine because I would prefer O log n, but because it's not going to be sorted and we don't want it to be sorted, that's not going to happen. So I'm going to be fine with a linear one here. The only issue here is going to be, so what's going to be, like int. Or of yours. I mean, that's always happened. I mean, it's literally the same. Let's see, what am I doing wrong here? Vec begin, vec. Yeah, what the hell's going on? Find. No suitable conversion of to int exists. Yeah. Yeah, but I don't care about the true or false. I mean, I'm pretty sure that, as this says, the basic implementation is extremely simple. So we're just gonna code our own. So we'll just do, so we can't use a while loop. So so here we do is return 0, and what we do else is we do return. So if turns I equals v, return I, but that's not exactly right. So I'm pretty sure we're gonna get an off by 1 error here, because I think let's see. Yeah, so don't worry about it. Oh, no, you can go away. I want to go to the, to here. Let's see, 0, 1, 2, 3, 4, 5, 6, 0. Well, so that sort of works, but turns up pushback. So the last val is 6. So it's going to be 0. Let's hear the last spoken number. Since it had been spoken before, the last number to speak is the difference between the number of turns it was last spoken, 4, and it was spoken most recently. Turn 1. Thus 4 minus 3 is 1. Ah, okay. We actually, yeah, so we want to go backwards. First of all. Because we want to find the last moment it was spoken. So that's fairly easy, thankfully. Because we just do, there we go. So that's just the other way around. That's easy. Then what I want is, oh. Expressions of the, oh yeah, I know why. Ignore. Just go away. I know why. I know why. It's because this needs to start as small. And it's actually, it can go up to 0, so it'll be equal to 0. There we go. Yeah, so it's still not correct, but hey, we're getting there. So first of all, so what do I actually do? So the last set was 6, so yeah. So let's do that here, just so a little bit better organization. So it should say 6, which is 0, it's correct. But then the last value is the one before, which is 0, but that has been spoken before, which is that one. So why does it return 1? It returns 1 because... Why does it return 1? So see, the last time was 0. It has a term before when it was last spoken. Because we'll always do it with the last set. Yeah, last set is 0. And then it should find it in the first position. So let's just do it a little bit shorter. Just do like 4 turns. What am I going to do? I think I'm doing an off by 1 error here, but I'm not sure what. 0, 1, 2, 3. Oh, yeah, I know why. Because it, I know why. That's better. Not better, actually. Wait, no, so you find 0, and then you do I minus 0. So what I can do is I can do here I, so we can do like turn. Then we return turn minus I. Yeah, that sort of should work. Okay, let me think. So last set is 0. This is going to be 4. Because it starts at 3 and then it goes to 4. And then it finds it, and it's going to be finding it at position 0, which is index 0. So it returns turn minus I, which is 4. That's not the right answer, because I know it needs to be 3, because it was actually the first place it was found. So that should be like -1. But that just turns it into -1, which is not what we want. And it'll just break. Wait, why does it become 0? Now that's just being weird. What the hell? What is going on? So 0 is 0. Do I not assign something properly here? What is going on? I mean, this should be hit, right? Find found last set equals I. Turns I equals V. Off by 1 the day. Yeah. So let me just, well, we have the count I here. So let me actually do it before and after, which, okay, shouldn't actually give me any information. Because it'll literally just echo what was the line before. Yeah. So that's not an issue. That's not a special count, exactly. Let's go through the logic. So we know that it has 0360 in it when I'm here, and it knows the last set one is 0. So it starts 2 ago, because we don't actually want to get the previous time it was said. We want to get like the time it was said before that, because we always check the previous value. So but no, if we actually do want to know, yeah, crud. Yeah, I see my error here as well. I see what's kind of wrong here. That's the issue I mentioned. Yeah, now it's -1, which is fine because we find it here. The issue is like here when it said just before. So last turn was 3. Most rogue more recently. So the 6 number is also so here like 3 and 3 follow each other up. That's fine. No, that's fine actually. That'll work fine because we know already our last 5. That's the value we're looking for. That's V. Int I is V is over. If I turn I equals V. That's all correct. Would you? Thank you. Give me the wrong answer again. So this is weird. So it says that 0 is in 6. That's not right. Find found last set I. Last set is gonna be 0. And then yeah. Go next one. I is gonna be 4. Wait, why is it 1? Turn size. Wait, that's not Dassy. That's the issue. Why does it say turn size -1? Turn size should be 3. So it starts at 2. I think that's the issue. I think that's the issue, actually. It shouldn't do it -1. Nah, it's not much better, actually. First of all, so let's actually grab, turns.size u. Actually, let's grab, so int t size, just so I don't have to recalculate that because I'm going to be using the t. Yes, okay, see, this needs to be in here. That's why, I think. Why does it say 1? T size is... Yeah, so T size is 0? Did I need to use length? What? Okay, what's going on? What is the size? Turn limit is 4. Last time, yeah, sure. Turn size is -1. What is... What the hell is T size? It's 1. What? That makes no sense. Oh yeah, you know why? Because Nitro's a goddamn fool. That's why. I think that's the issue, actually. That should say solve that. That's a bit better. Yeah, there we go. Let's go back to what we had before. So, because that is way easier. Because then I is just the turn number. So we don't have to be stupid there. Yeah. So why do you say 2? because you're 3 minus 1. 0, so 1, 2, 3. Yeah, because you're... That's why. Just because you should be +2, yeah. 4. But that means that I should also put you there +2, because that's the actual turn number. And now I want more turns. Now I want to turn 10 turns. Fucking sort of off by 1 errors. Wait, why does it stop? Oh, what the hell? Why did I never change turn limit, you doofus? There we go. Still not entirely correct, but we're getting there. What are you complaining about? Turn is unidentified. What? What do you mean identified turn is on what hour? Alright. So 0, 4. Yeah, so that's not right. Of course, then it'll screw up everything. Because I think it needs to return this minus what? So it finds 0. No, because we do here +2 minus 1. So +2 minus 1 is just +1. And then... Okay, let's just set it to... Because I is the turn, so that will be turn 4. Alright, so let's see. I need to actually do this proper. Because we don't... Indexing is all fine. That we're never going to miss index here. So I is going to be the next one, so this should actually be turns there. And you're going to be +1 because the turn is going to be 0 index, which is fine because that's how it works. And then what you find, so this is going to be a 4, so this is going to be a 3. And so you are 6? No, so you're 0. And the first one it'll find there is going to be in the 0 index. So yeah, 4 minus 3, like you should be -1 because we always get the difference and they want just like 1 before, you know. There we go. 3, 3, sorry, 0, 3, 3, 1, 0, 4, 0. It seems to be working. So then what I do is I just do this. And then I do for, what, 2020? And then I do count last said. Not sure this will be off by 1 though. What would be 2020th number spoken? 436. 436. 436, right? So let's try it with the other ones as well. And that should be this done. Let's see. 1, 3, 2. I need to separate. I need to remove the commas because screw this. This should be 1. 1. I'm confident enough. What's the worst that can happen? Four, 7, 5. Let's go. Part 2. Yeah, exactly what I thought. Exactly what I thought. Have fun doing a fuck ton of numbers. And this basically says, yes, switch it to your other input nitro. You should have done that earlier, which is fine. That's... well, I guess I could have anticipated that. Yeah, but they're meant in such a way that searching back is going to take for fucking ever. So there's no way. And look, you can see the vector resizing. Yeah, this is just going to take forever. So, and now we're going to go to my other idea, which was, let's commit this. So, the one that I should have done in the first place, but I didn't think about doing, because I'm lazy. So we're going to switch to a map where we just keep track of the last seen position of a value, which is far easier. Let's see, clean up and a 15 part 1. The good thing is this one will actually work for part 1 as well. So that'll be easier. It's slightly more clumsy because now we're going to be doing some weird lookups. So instead of a vector, we're now going to have a map. And it's going to be int, which is going to be the value and the turn when it was last seen. And we're now going to push back term. We're going to have an int I equals 0, and we're going to be doing something very simple, because we're just going to be doing map n equals I plus plus. Should be turns, actually. I like this way more than doing it the other way, because that is very verbose, and this is easy peasy. So let's first bring it down to 2020 so we can actually see. So now I already know what my answer should be. That's fairly simple to put this back in. Although, actually, no, let's not do that. Let's start with U3036 again. It's probably better. Because what we're going to be doing now is we're going to be... Well, so this one is fairly easy. Just do I equals last said. Sorry, it's going to be the other way around. Last said equals I. I think here we are going to need to watch out for off by 1 errors. So now what we're going to be doing is fairly simple, because we don't need this anymore. We just do a find. Actually, there's no find. What we literally do is we do... yeah, we do have to find it, because we only care about the previous name. We don't insert it yet. We do that afterwards. So now what we do is we... Oh yeah, it's already going to be... So here's the danger updating this thing. Because what we need to do is... So it's 036, that all gets put in there. So we have 003162. Then we're going to have 0. So this is going to find 0, because 6 wasn't said. So we're going to find val last said, which is 6. Right? Yeah. So 6 is going to return 1, because we're going to try to find... So let's see, last said is going to find val said 6, which is not going to be in there yet. And then it's 0. That's easy. So all we can do is just return 0, which will be at the end, because what I'll probably do is like turns.find v does not equal turns.end. Here, like if turns... Basically, we could make this a ternary. So if turns does not equal that, sorry, then we found it. So then we can do turns, like return turns v minus turn. But that's not going to work right now. And I can show you why, I think. -1. Impressive. First of all, let's make you 5. Oh yeah, and you need to be turns.length. Is it really size? I thought that wasn't gonna work. -4. What? Oh yeah, because of course. There we go. Wow, 5 gives -4, which is a total bogus answer. Wonder why. Okay, do 10. I want to see how this iterates actually. Oh, that's wonderful. Yeah. Let's see. That's a really weird one. Wait, what? If turns.findFeed is not equal to turns, which is gonna be turns.find will be the pointer to where the value is. Wait, what's going on here? So this seems to work fine because it. Wait, why are you turns.size should be what? So this should be 4. Why are you the wrong value? Nice turns.size. Well, first of all, we can always make this 0, so we always see the value that was really returned. Yeah. Which is the right value, but not because we adjusted it, because it should be something else, of course. Should be I. There we go. Let's see. Turns.find v. So what are we gonna try to do? So yeah, because you are that value. So we're trying to find 0. So we're trying to find 6. 6 should not be there. So why are you able to find it? So what's going on here? Let's rerun this so it tells me -4. Because I think it returns 0 if you don't find it. I'm not entirely sure, but why do you turns feed -0? Actually, so how about you return? Actually, do plus I. That's easy, slightly better, because now it'll be not a 0 index turn number. Slightly better. So what we could actually do here is the same here. I'm just gonna. This is not needed, but hey, I would like. I'm having an error somewhere, and I'm not sure why. I think it's simply in how I'm using maps that I'm just doing something wrong there. Yeah, so 0, 1, 2, hey. But that's of course not your true value, because I can just simply put that here. There we go. What are you complaining about? Missing closing quote? What? What do you mean missing closing quote? There you go. Goddamn Visual Studio. 1, 2, 3, 4. Hey, there we go. So 0, 3, 6. So this should return a 1. Because it was found on the first turn last. So sorry, 0 was never found before. So you should return. So now we can look here. So here's the error. So what happens if I just do count turns v? Just always. How do you give 1? What? So last side was 6. 6 is in there. I mean, the only thing that I'm assuming, because I know that I'll have another error here. Which is a bit frustrating. But this is, even though the first one, it doesn't work. Why do you find 1? Okay, you know, just for pair int, comma int, p in turns, count, p dot first, p dot second. What the hell's going on here? 0, 1, 2, 0, 3, 2, 6, 3. So that's what the hell? Why is 0, 1? Also, where's the 2 coming from? What the hell? What? Also, this is not right. So 6 is 3, that's true. But 2 should be 1? Turn n equals I. So turns 0 equals 1. That's good. Turns 3 equals 2a. That's good. But where does this come from? What is going on here? Yeah, no wonder it's giving wrong errors. But what is this? Turns is empty when it's initialized. I am very confused here. 0, 2, 3, 6, 1. It's like a turn 0 already got initialized somewhere, but there should never be. Columbus must have been following your maps to India. What is going on here? Because, okay, just remember, these values are reversed in here. So 0, 1 is correct, but there's no 2 in here. So where does the 2 come from? Where does the 2 come from? Is it because I'm like changing n? No, because there's no way it's keeping pointers. No way. Okay, let's do it this way. It's a bit stupid, but you know. See where it's getting entered in. Now it's... Wait, was it just me being stupid? So now it's not there. Wait, is this a fucking assignment? I mean, no way, right? What? Oh, no, it fucking is. Jesus Christ, you blithering moron. Yeah, no wonder something goes wrong. Look, this should not be this, first of all. Jesus Christ, you are an idiot. So first of all, this should be whatever the size of this is. So it should be I, actually. That was weird, but I guess that is causing an error. Yeah, go away. Don't. Well, we actually need you for a second. Okay, we don't need you anymore because you're correct. Yeah, because this is the end of the map. So that's why it says 0. So that's fine. I think something went wrong there. Yeah. So, here we go. Last set should be 6. Why the F is it? Why? What? Well, okay, fine. We can just do it slightly different. Actually, just do that. There we go. Zero, 3, 6. So cut. So it's 3. What the hell are you 3? What? What the hell? First of all, turn dot size. That is 3. Oh. Yeah, I guess we do plus I, so that's fine. 3, 0, 4, minus 1, minus 1, minus 1. I should be... So it turns out it's going to be 3, but you need to start with 4. No, wait, because... Yeah, so you should actually start at 4, because I'm no longer using 0 indexed turns. That's fine. But why do you echo 3 here? Because V turns... Wait, turns V. Yeah, sorry, that's the last turn the value was said. So let me actually just, you know, count the whole blithering lot here. Man, I love this debugging. Especially when it's like 99%. Is it Sanic? Yeah, Green Hill Zone. Yeah. Oh, well, that's why we don't need that here. There we go. There we go. So V is 6. That's good. Turn is 4. That's good. Turns V is 3. So this is the issue. So we know it's been said before, but that's our current turn, like, as it were. So we know it's never been said before that. So what I would need to do is kind of keep the last 2 values. Or I need to change my updating structure, and I think that's probably the best way. But then I basically need to... like, not update it here. Or basically... Why are you complaining? Expected a semicolon? No, why would you expect a semicolon there? Fucking C++, man. So what I could do is I could make this a pair of ints, I think. That might be better here. So what I can do here is, it's not going to be I, but it's going to be pair int, so int, comma, int of... Because now I can fairly easily determine if it was... So the first value is going to be... So it's going to be the value seen at turn... Seen last at turns index n. And before that at turn, you know, other n. So n1 and n0. So now what I know is, okay, it was now seen at I, and before that it's at -1 or 0 in this case, because there's no turn 0. And what I can do here is say, hey, it was so turn last set. So that's going to be our new value, which was set last at this turn, and before that at let's see. So if it's the first time we're going to say a value, it's going to be this. If it's otherwise, this is supposed to be this last set value, pretty sure. And then what we need to return here, it's going to be slightly different as well. So let me see if I get this right. The last seen at this place, which is the current turn, because that's of course, and last set is when we last set it. If it's the first time we say a value, this will be 0. Otherwise it won't be. So we're going to be doing last set is going to be, should be 0 here. because 6 is new. Because I basically want to return here. I want to do return turn v dot second, basically. Minus the current turn. Because turns v, oh yeah. Because we'll have a dot first, dot second. So this will still break, but just want to test it a bit. There we go. So 6 4 3. Oh yeah. Man, it feels really stupid doing this because I know that there's a far easier way, but in theory this should be fairly simple. There we go. So let's see. So yeah, 6 4, which is the turn. It was seen at turn 3 last, which is of course the previous turn, because this will always be last turn. 4 5 6 7. It's good that that works. 0 was seen before, so what I can do is I can a value will always be seen before. Okay, that's actually pretty good, because what I can do then is just return turns v dot second. Really? So that's gonna be it then, I think. Okay, so that's not so, but that's good. So 4 0. But then of course 0 was not last set at 0, was last set at 1. So this is fine. So we last set it here, and then I need to find. Then I need to do turns dot v. Sorry, last set dot first. Hey, this is great. That should work. 0 1 0 4 0 and 6. That's not correct, but a man can wait. Okay, so 0 was last before said. So 0 was last set at turn 5, was last set at 4, and now it's 1. So we return turn minus this, but that's I need to watch out. Because what we so here I want to return. Ah yeah, so if it's 0, so if we can do turn v dot second equals 0. If it's 0, return 0. Otherwise, return turn minus turn v dot second. This should be fine. What are you complaining about? Because it turns with that plural there. Thank you. Very cool. 0 4 0 3 is all wrong, but sure. So it's 0 here. That's correct. So this should return turn 5. Ah, yeah. Then we should return turns first minus turn second, I think. Yeah, that should actually be it. Because first will always be the higher value. 0 3 3 1 0 4A. I think we got it. So let's quickly get rid of the counts and then go to 2020. Oh, ha 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 ha! Nitro, you're a goddamn fool. That's for sure. Just to make sure we can always count it later anyway. There we go. Should we select 4 3 6? That's wrong. Blocks. What's going wrong now? Yeah, that's not right. Oh, it is. Off by Dutch. Yeah, so here we go. 0 3 6 0 3 3 1 0 4. Check one more. Oh, I know why. See, this is correct, but now we're off by 1. You know why? Because it should be 2021, I think. Or it's 2019. It's either of the 3. Maybe don't do that, Nitro. Well, actually, you can do that one, just not do all of them. Because this shouldn't take that long. There we go. 436. Perfect. We got it, kids. Just off by 1. So, just to check, it also gives us the right results for the other one. For the original answer. So what we've done now is we never have to check that many values. Oh. So this is like 475, I think. And then we go for the other one. Which really shouldn't take that long. Okay, it still might take quite long. Boy. What? 15 megabytes, 16, 17, 18, 19, 20, 21, 22. Is there a memory leak in my program? I'm not sure. What mistakes have you just fixed? Wait, what? What do you mean? What do you mean, what mistake have I just fixed? God, it's... Okay, let's do... what I can fairly do is... if I... So what do we have? 30... Can I do this here? I assume so. I can, so it's 30 million. So let's do if I... 1, 2, 3, 1, 2, 3... Let's actually do 1 with 0 less, so... But then we have return limit the right answer. Actually, it was 475, which is the right answer. Let's do it in release mode, so I don't have to wait for an age here. We need to see 300 of these. Wait, what do you mean? What's wrong, Hamster? Assigned to turn limit. The correct number? Wait, was it 2021? Yeah, Christ. Whoopsie. Right? Just sanity checking. I think I need to do 2021. Yeah, so it's actually it's this value. So one of the things I actually kind of like about Java is that you can, in numbers, you can put underscores. So what you can do is when you have like groupings of 3, you can just add underscores there to actually like put in like whatever, like how many zeros. You can count millions fairly easy. Holy fuck, this is slow. Jesus Christ. But we got the right answer. I assume I'm not first. Far from, probably like 4th. Yeah, 4th. Sounds about right. Me waking up latest after-ish. Hamster, me and C-Fusion. But oof. I shouldn't have caught that. Well, I would have known if it was wrong. Anyway, holy fuck, that is slow. How can I speed this up? So, I assume you two did mostly the same that I did. I'm actually going to keep this here so I actually know what's going on. So this one, I could just make... this. So V is going to be last said. Yeah, I'll take a look. Give me a second. Let me just clean this up a bit. So just, if I want to test this, I'm not going to be putting in the older one. I just make sure that I can actually, what do you mean V is undeclared? Oh yeah, because you should be less said. My delta would have been the same if I hadn't dermed with extra array. Oh yeah, deltas, eh? What's mine? 43 minutes? It's fine, I guess. It's not great. But it's mostly bumbling around by having to rewrite my entire method. Wrong day. You're right. I'm annoyed that it doesn't do that. So 30 minutes. Sounds about right. But yeah, you're right. No, I thought it would automatically go to the newest day, but it doesn't. Anyway, after 48 seconds, I guess you wrote your day, like, I would have had this as well, sort of, if I just, didn't say an hour ago to myself, Nitro, this is a smarter way, which we probably will need for part 2, but hey, I gambled wrong. Yeah, basically what I did, just slightly different. Just grab a dict. Yeah. Slightly easier here because the syntax is simpler. Append 0. Yeah, you do it slightly smarter because I would have avoided my pitfalls that I had with this. Because in theory, this will be 0. Yeah. So, and what did Hamster do? I assume you did basically the same. Yeah, I think you do something like my, let's see, if next number in else flag is 0, what? Oh, if flag is 0, next number will be 0. Yeah, that's actually pretty smart. Oh, and then you just, you get both part 1 and part 2. Yeah, I guess I could do that as well. Well, I don't need to do that here, so screw it. Not gonna do that now. Yeah, smart. That's pretty neat. A cheesy 5-liner. Yeah, let's see. So it's the numbers, num times. Yeah, so that's just initializing. You could put this just in here already. I'm not sure if that'll work. No, enumerate. Yeah, you can. Just do enumerate. I know. Just do enumerate. Can't assign in generators. Oh, really? I did not know that. I thought you could do something like, for, I, comma, V, it's a pair, eh? Besides doing it wrong. Enumerate. Yeah, so you can't do that. That's a shame. Oh well. See, num times equals length. Numbers plus 0. Yeah, it's the same thing you did before, just cheeky. I mean, the thing is, my calculations like this code is reverse. Yeah, it's I know. I mean, I could do this, could put this here. Here we go. A bunch of lines are gone. Assignment I have to do, which this is like, if you discount my reading, my entire solution is also 5 lines. And this I could compress even more if I want. Sorry, this one doesn't count either. So, it's literally 2 lines. And even these I could condense it into less. I do I mean, I could do this. Ooh, if I equals 2021 or I equals, this thing, count. So it's just, it's, yeah, exactly. I'm not gonna, there we go. So it's like, it's not exactly much. So maybe you should do wild true. You could do, yeah, you could do that as well. For less checks. Yeah, I don't know what the bottleneck is here. I guess you also don't have to like do this crap. I guess I could just do this immediately. No need to put that into a string. Yeah. Yeah, this is about as small as I can make it. Like, half of these are not needed, by the way. I just throw it there so I can always use what I would like to use. Yeah, this should separate this. Well, that's this. I'm fine. I'm happy with this solution. It works. It's not fast, but I wonder if there's a... Is there a faster way to do this? If you know, let's see, day 15, part 2. Because, let's think about complexity. You're gonna always... Maybe there's a pattern. Yeah, that's true. I'm pretty sure there is, because these, like, always have a pattern like that. Because what I think happens is that... you're gonna like keep counting up, you find a value, and then you reset it, and then you count back up. Like after you've passed all of these, I think you get into a pattern of like counting up to the highest value, then resetting, and then counting up to the highest value again. But that's maybe for a different number sequence. Because it to me feels like it might become something like that. What is that? Don't know the Van Eyck sequence. Yeah, so exactly. I watched this video. That's what I'm thinking about. That's why I'm thinking, oh, there might be a pattern. But I guess if there's not, I believe you. Wait, who else solved it before I? Wrong one. I want to go to the subreddit. CFusion did it as well. But do we have his code? This says when the video that there is no pattern. Okay, thank you. Well, I believe you. Because then I was thinking about a different one. Only thing we know is that there is no maximum, which makes sense, I guess. You have it's off by one. Wait, what? You have it's off by one. What? What do you want about Affish? Do you mean I have no repo of him? I think I do. Where is it? See if you. Where's this repo again? I still. Because it's not in my overview. Okay, I'm stupid. Could you just give me the link? I don't know where it is. CFusion code. Yeah, where? Because I see him posting here, but... Oh, there it is. There it is. I got it. Yeah, it's an image. Damn repo, man. Just stop doing it like this. Default dicts from the lists. Same thing we did, basically. Yeah, I have a feeling this is going to be... White theme is disgusting. I have a feeling this is going to be another one of those days where it's literally going to be everyone did the same thing. Okay, you notice we're off by 1 hour. Is it another one of those that you should go to 2021? Is that Pythonic collection? Seems really Java object. Wait, what? You mean this one? This is Python. 2019, actually. Oh, it's an... I mean, that would be my first instinct, because that's my error at the end. It was like, oh, it's off by 1, because instead of having 0 indexed turns, I had 1 indexed turns. But wait, how do you get that? How do you not try that? How do you not... What? God damn it, CFusion. Get your head out of your ass. I'm done already, by the way. I'm not sure when you popped in there, GGL. Fairly simple solution using the naive turns implementation. Not that I think that there's a smarter way. Guess we're gonna find out now if I'm an idiot. Yeah, I'll maybe rewatch that video afterwards. It's always nice to know more about it. Yeah, yikes. Yikes, that's painful, man. To just have an off by 1 error. But yeah, at that point, you would just count it out. And you see, hey, oh, that's the right value. Let's see, PowerShell took about 30 seconds. Yeah, I have a feeling part 2 is going to take a long time for everyone. Yeah, this is just, I like the Vim one. It's pretty neat. Yeah, I'm not going to attempt to run it for part 2. Yeah, I really should have guessed that part 2 would have been optimization. Yeah, short Python one. Pretty quick one. But I would like to know, let's see, what did they do? Yeah, it's basically the same. Unordered map? Is that going to be faster? Values.count cur equals 0. Otherwise cur minus values, yeah. It's OEIS sequence. Yeah, let's just start from 0. 0, 0, 1. See, I did recognize the sequence. Okay, I recognized it because... Well, sorry, I didn't recognize it per se because I thought I was more organized, but I guess not. Hey, F to pay respects. Nice. And being quite simple. Yeah, the thing with this problem is mostly that the logic is still fairly complicated. I mean, if we look at the... Where did I have it again? The VanEck sequence. Here we go. This logic is not extremely easy to comprehend when you first read it, even if you did recognize it. So implementing that isn't fast. And then, of course, you get to part 2, and you better fucking hope that your initial implementation was efficient, because mine sure as shit wasn't. But I knew a vector implementation would be very simple. But I already could have guessed that it would be awful for part 2. To find a cycle, it would probably never happen. Just brute force it. Do I have 2 map lookups? Yeah, I do. Well, I think I might be able to actually get a pair int, comma int. P equals, I think I might be able to reduce the number of lookups here. Yeah, I think that's actually what's making it very slow. Be careful. Don't do it here again, because that's only 1. Curious how long it'll take now. I do like that they actually give you all different inputs, because it allows you to stream it very easily without giving anyone the answer. That's a bit faster, I think. But look at that memory going up. Good grief. It just shows you how many goddamn values there are in this thing. It's ridiculous. I mean, it still takes a little under 20 seconds to run, but Jesus Christ, that's so many values. Dialogue. I guess dialogue will be pretty fast here. Hey, look, same guy had the off by 1 thing that CFusion had. You don't have an array as a primary. There's a system function that allows to keep an array in hash states. Wait, 1.8 seconds? Wait, what? Function play. Limits? I am not entirely sure. Yeah, 18 second in PyPy. Wait, PyPy is 6 seconds? What is your code? Still 18 seconds, but it's surprising because usually C++ is a lot faster, but I think that this memory structure is a lot faster. Unknown word, default dict. Thank you. Let's see. Yeah, I'm just a bit curious. So what's the faster? So there must be some, just learn this one simple trick to speed it up by a fucking million%. Because I'm reducing lookups. I always need to do a lookup. I always need to do this logic because yeah, I always need to do this logic. Is this, there's no way that this is actually taking time. This check might, so I could remove this and see how much faster it is. Then let me just add chrono stuff. And I'm kind of curious how fast it is, so we're gonna ignore reading it in, because we always do, because fuck file IO. And then we could have there we go. So this should tell me how fast it is without that check, because it's another modulus operation every time it'll still be like 10 seconds at the least, probably 20. Well, it'll be 20, I think, because counts really don't take that much time. Well, there we go. So it's just do seconds, please. I think it's 17 seconds. I think it's 17, yeah. Which is, I guess, good, but it makes me feel that either I'm doing something stupid or this the compiler is being slow. There we go, 16 seconds. Yeah, it should actually not be US, but it should be seconds here. But hey, 16 seconds is alright. Bit annoyed it doesn't give you the nice round digits, but I guess it makes sense because you're telling it to round. I could use milliseconds for that otherwise. Anyway, unless someone has some really nice insight for this, which I could speed up my code by massive amounts. Everyone does brute force. Hey, managed brute force part 2 in under 800 milliseconds. First, oh, okay, so map is slow. So what makes it fast? So what data structure are you using? Main, here we go. Assert, yeah, fine. Game 1, 2, 3. So game is the initialize a list of nums. Speak in. Wait. You're using a vector? How the fuck is a vector faster? Wait. Get turn sort resize. How is this faster? In spoken is 1, 0, turn number, yeah. Oh, you can use apostrophes and numbers here. Okay, that's kind of neat to know. Dot get turn. So get turn. Yeah, so it resizes the turn before. Ah, okay, that's smart. So you basically resize it. Ah, okay. Huh. I wonder if my part 1 solution would have been a lot faster with that as well, because you're still... But how does he search for it? Let's see. Yeah, because he just does the same kind of lookup I did, but a static cast a size T might help there. I'm guessing that memory resizing is super slow. Ah, that's it. Interesting. So my part 1 solution was actually fairly fast. It just... Interesting, actually. Yeah, but he didn't have to do a search. But wait, how do you find that? So, because you're looking for a value, so yeah, turn. Int n is spoken. So you initialize it, so that's fine, because then you do speak, which is basically just puts it in there. So auto p is turns num. Num is the turn, I'm gonna guess. Or is that the number you want to speak? Yeah, speak number. So turns p in turns is still the turns is what exactly? Tell me. Turns 1,000. Oh yeah, so that's the default number when you don't have anything else just to test it. Which of course gets resized here to a number 1,000. So yeah, static cast num. So that'll be turns as a vector. Okay, I think I see what's going on here. That's pretty smart. So because it initializes to 0, you know that if there is no value there, it'll be 0. So, and then the p dot second, which will be the pair, because that's what's in there. The second will be an exchange, so you swap these two numbers. I think. I'm not sure what std exchange does. Exchange. So it just kind of swaps them, I guess. Oh, I guess it's basically std exchange. And then you increment it. Increment spoken. Yeah, so that's when it's... So that's how many times it's been spoken? Or I guess it's just a 0 and 1s? No, because you're going to increment it the more it's been spoken, and the last is going to be the number. Huh. And then for every single turn, you're going to do... Yeah. That's so... Oh, yeah, so you first figure out the number to say, and then you say it. Okay, so I'm going to guess that making a huge turn thing is really going to be the biggest benefit. But that's curious, because I don't think there's a way to actually do that here, but I guess the resizing takes up so much goddamn memory. So let's quickly see if I can get my first solution, put it into another file. What? Thank you for that, by the way. Oh, huh. Gee, Nitro, it's 2015, day 1. Oops, that's not the right day, maybe. Yeah, so what I can do here is just make a new file that actually is 2020, day 2, 2015. Whoopsie. So here we go. And then what I can do is do turns. So what is it, turns.resize or something? Turns resize. And that'll be turn limit, basically. Let's see how fast this is. One or more multiply defined symbols found. What are you complaining about? Is it turns.resize that is annoying here? I mean, I guess I could just do just very lazily just do this. Don't think I can do better to 20 seconds. Well, my naive solution is there, but I have a feeling that the memory aspect is going to be the biggest kicker here. Yeah, what are you complaining about? What do you mean multiple defined? Oh, I know why. Because we need to remove you from exclude from project. 6? Sorry. Oh, yeah. $16? What? What? Oh yeah, because turn size should of course not be that. It should be just do this manually, just go to 16. Still 16? What? I is less than turn limit. Turns outside. Oh yeah, because you should be like 1, 2, 3, 4, 5, 6, 7, 6 or so? 7? Yeah, so it already pre-allocated all 190 megabytes. Yeah, it ain't exactly as fast as his solution. Why the hell is it so fast? We'll have to. I have to start doing work as well, man. What the hell? Okay, so that's not exactly gonna make it much faster. In fact, it is far slower. So what's so fast about this? I have a oh yeah, of course, because this is super duper slow. So this I should not be doing. But that's, yeah, I already know what's okay. I already know what's going on. Let me just put this into the proper file and then delete you. There we go. I know why his version is better. He rewrote it slightly to actually don't have to do that search through. That's what makes mine so slow. That's also why my other day is so much faster. Rename file. It's why it's so much faster, the other one, because I don't have to do that search through all the freaking time. Anyway, thank you for watching, everyone. I have to go do some work. I'll be back tonight for sure with fucking World Tour. That'll be truly wonderful to play an amazing Tony Hawk Pro Skater clone. Truly, truly wonderful. Anyway, this day is done. I don't think there's anything else to look at. Anything neat here? Goddamn weebs, man. Alright. Gonna be clobbered this year. Oh yeah, so this is actually, I was curious about this. Because I remember last year as being way more difficult by now. And I have a feeling that this year it feels weird because, I mean, look at the previous years. So I was around for 2019 and 2018. I don't think I did 2018 every single day it came out, but I did try to do that for 2019. And this this feels familiar, you know. These having to work a lot of time on some problems, but this is gonna be weird. So it's not just me that thinks it's a lot easier this year, because last year, well, let me take a look. What was last year? Day 15. So 2019, 15. Fucking int code, man. All right, fuck 2019. Let's go to 2018. 15. Yes, this fucking problem. I remember this one. It was fucking difficult. This was genuinely it's very fun to solve, because you're basically like coding the AI for a text adventure, but it was a lot of work Because what you're doing is you're doing not just pathfinding, you're also doing like combat orders, and you have to do it right. Because you have like HP, and you have attack values, and all this other stuff. And, this was a lot of work. It was fun, but still a lot of work, but like, yeah, look, 2018, day 15, okay, that's maybe a poor example, but still, it gives you an idea. So I'm curious what's going to happen later this year. Anyway, cheers for me for now. Thank you for watching, everyone. Hope you have a good day, and I'll see you guys later.